My name is Gabriel Gonzalez, and this is
Angel Romero.
and we are teaching you how to solve for tangent and be able to graph. That's right, folks. So, what we need to do first is
The difference between tangent to the other quotient identities. Part A, you introduce sine and cosine and link to the triangles and finding side links to also be able to find angles.
through this, sine and cosine are seen in right triangles to be able to find either cosine of a certain side due to this angle or sine over some other quotient identity. And with this, that's where triangles come into this real life scenario. We also need to show how tangent is different because through that, tangent has asymptotes. And if cosine is a part of tangent in the equation, tangent equals cosine over, oh no, that is cotangent. Cotangent equals cosine over sine, while this is the opposite, sine over cosine. And if cosine equals 0 and sine in this sense equals 0, it would be a number over 0 and in the end equal something that is undefined. With that, we can see how asymptotes are made in this scenario in the graphs and show how graphing is different when you graph tangent. To continue, we need to see how tangent would be graphed on a graph and give you such equation to prove that it is possible and you could graph it on your own. This equation is
Y equals A parentheses tan B parentheses X minus C parentheses plus B parentheses.
Yeah, that is bx minus c plus d. So a in this sense, A
is used to determine the amplitude and would multiply against the whole equation.
A also makes the amplitude short or long, and in the end shows whether if the graph either looks like this or like this. And that's what A is used for. But overall, the next portion of the graph that is going to be explained is B, the B and C portion of the graph, due to how the entire graph is needed on determining the periods and how B and X determine how it is an important factor to be able to graph. We had a little fluke in the system, but to continue, the equation that we are using is
Y equals A tangent B parentheses X minus C plus D.
And with that, we are looking at specifically B and C. B and C are used to determine the period, and more specifically, the endpoints, which are asymptotes. With that, tan equals sine over cosine. So if cosine, as I said, equals 0, then tan is undefined, making only 3 graphable points on the graph available. With that, you would plug in your variables and solve for bx minus c equals negative pi over 2, and then determine the first asymptote, which would be start. With that, you then need to find the end asymptote, where it would be bx minus c equals negative pi over 2. Oh no, regular pi over 2, my bad. And with that, that would be the end asymptote, so you could find the correct periods on how the graph looks like overall. After finding bx minus c, you would then find d in the equation. And in the equation, it would look like this. Y equals a tangent, parentheses, bx minus c plus d. And this is d right here. D is
used to determine a shift in the graph to go up or down. D is added to the y-intercept and is done in the end after x-intercepts.
And that's how it would look like. This would be the y-intercepts. You would add whatever the y-intercepts are. If it is still undefined, plus d. Damn, I cannot spell. Sorry for that. But it would still, in the end, be undefined. And for the regular points in the graph, the 3 points, whatever they shall be, you add whatever d is, and it will determine if your graph starts from here and then ends up moving up or ends up moving down. And that's how d looks like. With that, you can now start a problem on your own, but in this case, I will be showing you the ropes and help you in this journey of math. So the example being used is y equals tangent 2x plus 2. So in this graph, it would have to draw like this. Just because I have good points doesn't mean I'm going to be accurate, so sorry for that. But with that, we have to start up and look at a in this sense. The regular equation will look like this. Y equals a tangent bx minus c plus d. Oh, I messed up right here, but it is plus 2. So that just proves d is 2, and with that, you also get to see how b is also 2, and there happens to be no c, so you saved yourself an extra step, and no a if there's nothing there. But yeah, that is pretty much it. And now you'd be able to solve it through plotting your points on the graph. So to go here now, I'm a big writer, so I'm going to use this entire page. I would set up my coordinate points first, and then not fill it out at all, because you got to find out how this equation looks like. And with that, you'd have to start your start and find your end. And with that, it would equal
Pi over 2.
That is right. So the first equation would look like this. It would be 4x over 4 equals negative pi over 4. It would be 2x over 2, but to make it the same denominator, it would have to be 4. So it would be times 2, and that would be that. To continue, it would end up being x equals negative pi over 4. And that is your starting point. And your end point would be the opposite. It would just be a negative turned into a positive, so it would be x equals pi over 4 for the end point. But in a more difficult problem, you would have to find how this would look like, and you would plug in through this equation. To continue, you now need to find
Points on graph. The original points on graph are negative pi over 2, comma, undefined, negative pi over 4, comma, negative 1, 0, comma, 0, pi over 4, comma, 1, pi over 2, comma, undefined.
And that is how the original line looks like for y equals tan x. But what we need to look at is how it changed through the new equation, which we have to do y equals tan 2x plus 2. And with that, we are going to multiply the inverse of b towards, and inverse of b would be 1/2 towards the x, and that would be times 1/2 times 1/2 times 1/2 times 1/2 and times 1/2. And the new points on the graph would be
Negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4.
And with that, we can also plot the x's on the graph easily. But to put this in the right spots, we need to find the y. And the y is just to add d. And d is this. D would be plus 2 to every single point. So plus 2 here, plus 2 here, plus 2 here, plus 2 here, plus 2 here. But if it's undefined, it would still be undefined. So this would be 1, this would be 2, and this would be 3. To continue, since we know this first rule, this would also be undefined. And then we have all we need to know for the new points on the graph, and can finally plot it on the graph. From what we have in our chart, we can finally plot the points on the graph. Our first would be negative pi over 4, comma, undefined. So this would be asymptote and make it look like that. Same thing we can already do to the other side since it's on both ends. And now we can do negative pi over 8, comma, 1. So it would be right here. Then our next point would be 0, comma, 2. And I already plotted it down. It's right there. Then our next point would be pi over 8, comma, 3. And that would be right here. And that would be how we do our graph. To shape it like our line, it would have to be like this. All this goes infinitely, and this goes infinitely down. And that would be how we solve our graph. So what we see in this graph is the points being plotted, and now that is how y equals tan 2x plus 2 looks like. And from that we could see this is how it looks like on the graph. We see our point right here at negative pi over 8 comma 1 0 comma 2, and right here pi over 8 comma 3 in some area right here, and that would prove our answer on being correct. Alright, some examples now that you guys could do on your own are y equals 2 tangent parentheses 2x plus 2. You could do this one as well, y equals tan parentheses x minus 3, or the most hardest one in this list, y equals 2 tan 3x plus 4 close parentheses minus 3. And yeah, that is the end to this lesson. I hope you now know how to solve tangent and graph it, and now can teach others this lesson. So have a good rest of your day, and if you have any questions, put it down in the comments below.